Hello everyone, my name is Jia Arora and my student ID is 2510999107, and this is my submission for task 8.1c from Object Oriented Development. So in this video I will walking through three things: how UML represents classes, fields, methods and relationship, how my diagram connects to my actual code, and why using UML before writing code is so beneficial. So first, how UML represents classes, fields, methods, relationships. So if we see this UML diagram, in this UML diagram every class is drawn as rectangle divided into three sections. The top section holds the class name. For example, here we have account, bank, transaction, deposit, transaction, withdraw transaction and transfer transaction. The middle section holds the field or attributes. The format is visible symbol, comma, then the field name, then a colon, then the data type. So for example, in the account class we have minus, balance, colon, decimal. The minus sign means it's private and the minus name, colon, string. The bottom section holds the method, same idea, visibility, method name, parameters and return type. So plus deposit, taking amount as a decimal, returning bool, plus withdraw, same format, plus print, returning void. So let us talk about the visibility symbol quickly. Plus means public, minus means private, hash means protected, and you can see that in the transaction abstract class, field like amount, executed, reversed and date stamp all use the hash symbol because they are protected and accessible to the child classes. Then if we see the transaction class, it is marked as abstract using the stereotype label up top. This means it cannot be initiated directly. If it defines a blueprint that deposit transaction, withdraw transaction and transfer transaction all follow. Now let's look at the relationship. The inheritance arrows, those hollow triangle arrowheads show that deposit transaction, withdraw transaction, transfer transaction all inherit from the transaction. This is a classic is a relationship. A deposit transaction is a transaction. The associate lines between the transaction classes and the account show that each transaction uses an account object to perform its operation. The composition diamond on bank shows that the bank is composed of accounts and transactions. It owns and manages them. That's a has a relationship. And the multiplicity label, the word many near account tells us one bank can hold many accounts. Finally, the menu option enumeration is marked with the stereotype double angle bracket enumeration, and it lists all the menu choices: add account, withdraw, deposit, transfer, print, history and quit. Then the relationship between the diagram and the code. So let us go to the code file now. So the UML diagram is essentially the blueprint and the code is the implementation of that blueprint. So let me walk through the key mappings. First, the account class. In the UML diagram, account has private fields, balance and name, and the public method deposit, withdraw and print. So if we see the second, the abstract class transaction, in UML it is marked abstract with the protected fields. In the code we have abstract class transaction with protected fields and amount, executed, reversed and date stamp. The abstract method execute, rollback and print are all there. Then the next concept is the inheritance. The UML shows arrows from deposit transaction, withdraw transaction and transfer transaction pointing up to the transaction. In C#, this is written as class deposit transaction colon transaction, as we can see here. That colon is how C# expresses inheritance. Then the composition in bank, the UML shows arrows from deposit transaction, withdraw. The UML shows bank contains many account and transaction. In the code, this becomes two list collection: list of account called underscore accounts and the list of transaction called underscore transaction. That directly matches the multiplicity shown in the diagram. Then the transfer transaction composition. In the UML, transfer transaction is composed of both withdraw transaction and the deposit transaction. In the code, the execute method calls withdraw from the account and deposit onto the account, making the composition real. So if we summarize, every class in the diagram became a class in the code, every attribute becomes a field, every method becomes a function, and every relationship becomes either inheritance, object reference or collection. So finally, let us talk about why I used UML before writing code and what are the advantages. So before I wrote a single line in C#, I drew this diagram to plan the entire structure. This helped me answer important question early. What classes do I actually need? What should each class be responsible? How do they relate to each other? Which classes should share a parent? For example, when designing the transaction class, the UML made it immediately clear that deposit, withdraw and transfer all share common behavior, so they should all inherit from one abstract transaction class rather than being written independently. Without a diagram, I might have written 3 complete separate and duplicated classes. Similarly, the diagram showed me upfront that transfer transaction needs to reference two account objects from and to, which shaped how I write its constructor and execute method. The advantages of this approach are better planning, fewer errors, better code reusability, easier communication, and overall it saves times also.